This is your online laboratory session for what happens in a collision. The conservation of momentum is one of the most important laws in physics. Momentum P is denoted as the mass times the velocity mv, and the conservation of momentum states that the change in momentum is zero. But this only applies when there is no external forces applied. As we will see in today's lab, the conservation of momentum can also be applied to a collection of objects. Therefore, we can use it to study the physics of collisions. Newton's laws are pivotal in studying the conservation of momentum. A pool table offers a perfect example of where we can use these concepts. When a force is applied, the ball moves at an acceleration. We can simply rearrange this to get delta mv, or the change in momentum. Therefore, the net force gives rise to a change in momentum. As the mass in this equation is usually constant, we can rearrange it so we get a difference in velocity, final minus the initial reference points. Remembering the velocity is a vector quantity also. For this example, the initial velocity at point A is 0, but the final velocity at point B is positive. Hence, we know that the change in momentum is positive, and so is the net force. We also see here where the ball moves from B to point C. Assume there are no external forces, including air resistance or friction. Therefore, we can say the change in momentum is 0. We have to also remember that momentum is only conserved in an isolated system. Now, when the ball moves from C and D and strikes the edge of the table, the final velocity is 0. Thus, the momentum change is negative, and when the ball rebounds from the wall, the velocity becomes negative due to the change in direction, and therefore the change in momentum is negative. We can apply all this to the collision involving two balls, or for this lab we are using two cars, but the two objects are treated as an isolated system. Therefore, the sum of initial momenta is equal to the sum of the final momenta. Also, the change in momentum of one object would be equal and opposite to the other object. For this example, the collision would be considered elastic, and from the lectures you would remember that both the change in momentum and kinetic energy are equal to 0, and they are conserved. We know that this is not always the case, and more often than not, for example a crash, it is an inelastic collision, meaning the change in kinetic energy is not conserved. So now let's review the summary of the equations here. Here we have the conservation of momentum equations for multiple objects within a collision. We also have the conservation of kinetic energy, and we can use both of these and solve simultaneously. Below is a list of hazards and controls specific to the laboratory this week. Please read it carefully before commencing the work and refer to it as necessary during the course of the session. Further details can be provided in the lab manual.
Alright, so here's our experimental apparatus. Again, we've got two photo gates and two cars. These cars have actually got little magnets in the end of them that will determine whether or not our collision is elastic or inelastic. They'll either repel each other or attract each other. On this side of the apparatus, we've got a spring that will give us a starting force to give us some motion on the car. And then as the car moves through these photo gates, it will trigger the timers and we can work out the velocities of the cars. These plastic springs here, the black bits here, they're just there to trigger the laser beam that starts the timer. So if I want to increase the mass of this car, I can take this heavy block here. It's got a bolt on the bottom here that needs to go into the wide opening on the car. So that feeds in like that. You can then slide it along, and then you can tighten the top piece, which will tighten that bolt into that opening so it doesn't. So this red box is the timing display for the two photo gates. To turn it on, you hold down the middle button on the bottom of the display, and then the rest of the display works with a touch screen on the display itself. To start measuring, you press the play button in the bottom left-hand corner. Then once this car triggers a photo gate, the time will display on these top two boxes here. So the box on the top left is for the photo gate on my right, and the box on the top right is for the photo gate on my left.
are many applications for the conservation of momentum, rocket propulsion being one of them. Another example is firearm discharge. So that is the end of this laboratory, so please ask your demonstrators if you have any questions, or you can always email myself.